The majesty of a jetliner gliding across the sky, how magnificent is the sight, how breathtaking is the technology and the ingenuity that transformed a simple invention into a lifestyle we know today as air travel. And not just a lifestyle, but a powerful engine that propels our economy forward. Aviation generated $1.3 trillion in travel and tourism, $38.8 billion from general aviation, 10.5 million American jobs, $237.3 billion from international travel, and carries approximately 40% of the value of all world goods. Aviation demand is expected to grow, tripling by some estimates, and our skies and airports are already crowded with different types of aircraft and airspace users. The aviation industry and government collaboratively strive to meet society's changing needs for aviation and national security. How do we accommodate this growth while safeguarding our already high levels of safety, at the same time achieving our commitments to diminish noise and environmental impacts? How will we meet the public's need for safer, more efficient, and reliable air transportation? How do we address the high costs of fuel with oil prices that now hover around $100 per barrel? And how do we reduce environmental impacts and our carbon footprints? How do we make technology work for us, and how does it solve our problems? The solutions provided by NextGen allow us to address these questions and begin to solve these challenges. NextGen is modernization, the movement to smart, efficient technology and procedures. Let's start by looking at some of our nation's airports, each with unique operational challenges and specific needs based on location. Atlanta Hartsfield-Jackson is the busiest airport in the world, with multiple parallel runways, a mix of aircraft types and operators, and high traffic volumes. Compare that to New York's LaGuardia Airport, with crossing runways, very busy airspace, and limited taxiways to maneuver, with limitations for expansion constrained by water and development. Chicago's Midway Airport is an operational hub, driven by short and closely spaced runways and noise-sensitive communities. It also has complex and shared airspace interactions with Chicago's other major airport, O'Hare. Seattle represents an airport with growing operations and interest, a new runway and associated procedure needs, and challenges due to terrain, weather, and interactions with the adjacent Boeing airport operations. These are just some of our airport, airspace, and environmental challenges, and there is no one universal answer to solve them. One of the most important safety and efficiency achievements to date is improving the way that aircraft can navigate. One fundamental initiative of NextGen is to provide precise, predictable, and repeatable satellite navigation, referred to as Performance-Based Navigation, or PBN. There are two key components of PBN. The first is Area Navigation, or RNAV, and the second is Required Navigation Performance, or RNP. Prior to PBN, aircraft had to zigzag from one ground navigation station to another. Air traffic controllers needed to block large areas of airspace around the aircraft to compensate for the variations in flight. With RNAV, aircraft fly more direct and optimized paths, and air traffic controllers can block smaller amounts of airspace. We get even more precise with RNP. The aircraft is contained within a narrow corridor, and the procedures can be designed with pinpoint, predictable curve paths that provide even greater operational opportunities. With PBN procedures and repeatable curve paths, we can improve flight efficiencies in all phases of flight. Let's explore how this NextGen initiative is helping to address the challenges of our congested skies and environmental concerns, from departure through the en route to arrival, and finally to the landing or approach phase. The departure phase. Atlanta's Hartsfield-Jackson International Airport, where 10,000 RNAV flights now depart every week. Because aircraft no longer are restricted to fly over the ground systems and navigation precision is greatly increased, we can create more departure exits or on-ramps to fly into the en route airspace. This expedites aircraft away from our airports into the overhead streams efficiently. For the airspace users, the traveling public, and the surrounding airport communities, this translates into departure efficiencies, which helps to reduce fuel, time, and emissions. Aircraft depart with minimal controller voice instructions, greatly reducing the complexity and communications between the pilots and controllers. So now we have the ability to create more on-ramps. So how do we improve the use of our runways to allow the planes up in the air faster? Options are limited for adding more departure paths and runways. The FAA is addressing this challenge by implementing new spacing standards based on the use of PBN. For aircraft departing an airport today, controllers launch successive aircraft on different courses or headings. This is limiting and uses large portions of airspace. The FAA's new standard, in use today at Atlanta, is called Equivalent Lateral Spacing Operations, or ELSO, and here's how it works. Using PBN, procedures can be designed that use less airspace, providing for additional departure paths from the runway ends that were otherwise not possible. The added paths increase runway efficiency without putting the planes any closer together. At Atlanta, this enables the controllers to handle the same traffic demand on 2 runways versus 3. NextGen is now seeking to expand this capability to other airports by developing a national standard.
The one thing about the ELSO initiative that stands out is, of all the PBM procedures we've implemented at Atlanta, this has bar none been the best one that we've done because everybody likes it. The tower likes it because they get a higher throughput. The TRACON likes it because we get to stay in RNAV all the time. The airlines like it because they get higher throughput and they get to stay on RNAV all the time. It has no adverse impact on the center, and it has not had adverse impact on the surrounding community as far as noise complaints go. So it has bar none been the most successful PBN implementation we've ever had.
Now let's look at the en route phase, where aircraft are transitioning to and from our airports. Because we are free from the ground-based systems, we can plan and fly more direct and wind-optimized paths and better address restricted use airspace. In some areas, we need to expand the limited en route road system into a highway system by adding routes where needed and otherwise not possible. PBN enables us to fly optimized direct routes or multi-lane highways to serve multiple airports and connect high-volume metroplexes. In the arrival phase, as flights near their destinations, we need to efficiently exit them from the en route or highway system. As more exits or on-ramps are enabled for the departures, likewise more exits or off-ramps are enabled for increased arrival efficiency. PBN arrival procedures can be designed to allow the aircraft to descend efficiently by reducing or eliminating the need for level flight. This design is called an Optimized Profile Descent, or OPD. OPDs improve how the aircraft flies from the higher altitudes down to the runway, reducing engine noise, saving gallons of fuel per aircraft, and reducing carbon emissions.
So that helps us save fuel, it helps us have a smoother descent path, and it also is a quieter arrival for the neighbors that we fly over.
It benefits the corporation from a cost perspective, it benefits the community from a noise perspective, and it benefits the environment from an emissions perspective.
In the approach phase, our flight is coming in for a landing. With more precise navigation, more accurate and curved path approaches can be placed where needed in limited airspace, improving access and providing greater options to avoid challenging terrain or noise-sensitive areas when possible. The FAA and industry are working collaboratively on advanced R&P concepts that take advantage of the curve path and narrow containment to eliminate mileage costs, impacts, and improve access. R&P also helps to deconflict adjacent airport traffic interactions that cause flight disruptions. In many metropolitan areas, arrival and departure paths at nearby airports can interfere with each other. This means that aircraft at one airport may be stopped on the ground or held in the air while aircraft at a nearby airport are landing or departing. At Chicago O'Hare and Midway airports, flight paths share the same airspace, which results in costly delays, cancellations, and passenger disruptions. A curved path R&P approach to Midway is designed to untangle the interaction of the two airports, enabling uninterrupted operations. The FAA has stepped up implementation of PBN across the national airspace. This is being achieved through collaborative industry, airport, and government teams who are defining procedures at our high-volume and complex metroplex airports with high projection benefits while abating environmental impact. In order to measure progress of this effort, the FAA is currently developing and testing a new PBN analysis capability that uses sophisticated analysis methods to assess airport-specific equipage, report on procedure use in all phases of flight, and to measure and report on the benefits of these new procedures. By using improved reporting capabilities, the FAA can better track usage of RNAV and R&P procedures, and with this capability, we can better evaluate where these changes are having impact and to make informed decisions for needed changes. PBN is opening up new opportunities and solutions across the U.S. and around the world. Thousands of procedures have been implemented to date, advancing our aviation goals and our commitments for bettering the global environment and the surrounding communities at our airports. This is an exciting time for PBN and NextGen, using innovative procedures that capitalize on current investments and technology, along with developing new means to measure and monitor progress. The FAA is building a performance-based navigational system to more safely and efficiently maximize this limited resource we call the National Airspace System.